Thanks. Now we are in part 2. So we'll be discussing the background knowledge required to understand Uttodaya. So let's look at binomial theorem. What does it mean? Let's say we have two coefficients, x and y. X plus y is coefficient of x is 1, coefficient of y is 1. Then we look at x plus y to the power 2, and that would be x squared plus 2xy plus y squared. Now you have to go back to high school mathematics. The coefficient of x squared is 1, coefficient of xy is 2, coefficient of y squared is 1. And then we have x plus y to the power 3, coefficient of x cubed is 1, and the coefficient of 3x squared y is 3, coefficient of 3y squared x is 3, and then there should be a y cube here. I missed the y cube, and that would be 1. So this could be obtained from here. 1 and 1 is 2, and then you put 1 on the sides, and 2 and 1 is 3, and 2 and 1 is 3 again, and then put 1 and 1 again. And the other interesting thing is if you add them, 1 and 1, you get 2, and then double the amount comes up here. That will be 4, and then here this should come 8. 4 and 4, 8, and this should become 16. 1 and 3 is 4, 3 and 3 is 4, 6, 3 and 1 is 4, and then 1 on the sides. So it'll be 1 and 4 is 5, and 6, 11, and 15, and 16. So the addition at the top is 2, and then it doubles to 8, 16, and 32, etc. Now each of these coefficients can be obtained using this combination equation. So n is, let's say, the 4. If n is 4, then that will be, this 4 here would be n, and we want the first coefficient, and m is 1. We want the first coefficient, so n permutation divided by n minus m. M is 1, so n minus m is 3. N permutation divided by n minus m permutation. In this case, if you are going with 4 and we are going to find the first coefficient, then 4 divided by 4 permutation divided by 3 permutation, and m is divided by 1. So that way we can find the coefficient at any location. Basically, let's say we want to find this one, third one, then n is 4, m is 3, etc. So this rule, this method was known to Bhaskara too. The product of multiplication of the arithmetical series beginning and increasing by unity and continue to the number of places will be the variations of number with specific figures. I don't know exactly how this statement comes up with this equation, but that's what he says. But we don't need this equation. But this equation was not known to the Sangarakkhita, the Uttodaya author, or not even to the Pingala. And as you could see, it was after Bhaskara too, and then later various European mathematicians. And then this is how you would get these numbers. So factorial n is n factorial 0 is defined to be 1, otherwise it will not work. So this means if n equals 1, that will be x plus y. So the x coefficient is 1 and y coefficient is 1. And n equals 2 is x plus y to the power 2. So the x squared plus 2xy plus y squared. So it will be 1, 2, 1. Here 1, 2, 1. And then the next would be 1, 3, 3, 1. 1, 3, 3, 1. This would, so n0 would be here. You would put m equals 0 and then n equals 4, etc. But we may not need these. If you don't understand, that's fine, because we may not need all these for our discussion in part 3. but this one you may need. Say, let's say the word samanale, the butterfly. Let's say sa is A, it's a sound, sa is a sound, and let's call it A. And ma is another sound, let's call it B, na, si, la, D, ya, E1, I just call it E1, and ya, E2. So you could see sound could be emphasized. And sa and ri are two sounds. You know, in Pingala he used the word lagu and guru, and this would be lagu means short, guru is long, or vice versa, I don't know. So one in Pingala's work he would use the short and long syllables. So different poems would have different syllable combinations. For an example, Set Siri Denama Gunamudana will have a different syllable structure than Maveni Bilinda Varavara Langata Kanda. You know, it's obvious. You cannot combine these two poems. You know, I mean when I say the poems, not the words, but the syllable combination. They will not go together. So there is a way that these combinations would come together in a poem. So certain rules were given how to compose those poems. In that part you have to understand. And now let's look at Pingala's work. And then he gave this, Pingala gave this sloka. And in this sloka he is asking the question, we have two syllables, G is for guru and L is for lagu. So if you have two syllables and if we have only one place to put these syllables, then you can put them either G or L. So we have only one, let's say one cabinet to put two items. You could put either G in the cabinet or you could put L in the cabinet. So two ways. And then if we have two cabinets, then you can put G and G in the two cabinets, or we can put L and G, or we can put G and L, and the order matters here because they are poems, and or we can put L and L. So there are four different ways. So here it's two and it doubles. And then in the three syllable you could put G, 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 L, G, 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 L, L, G, G, L. Basically he got these combinations. And there are 8 ways that you could do, and it keeps doubling. And he went up to 12 places, and today we can easily use these mathematics, 2 to the power 12 if we go up to 12 places. So the first place is 2, and the next place is 2, 4, etc. So basically this is the background knowledge that you require. And this is the Pascal's triangle here. This is the Pascal triangle, and we are going to see this knowledge is known to the Sangarakita in Uttodaya. Thank you very much. Please join me in part 3.